Hi, welcome to my video on relation is a function by definition. Definition of a function. A relation is a function if each independent value has only one dependent value. Let's look at an ordered pair. Okay, we have an independent value or variable, and we have a dependent value. And we could also classify independent value or variable as your domain and dependent value or variable as your range. Or we can also say the independent variable, which is your domain, is the x, and the dependent variable, which is your r, range, is your y in an ordered pair. A relation is a function if each domain value has only one range value. Not only independent, dependent, but could also be defined in terms of domain and range. Also, a relation is a function if each x value has only one y value. So independent, dependent, domain, range, x, y, or x, y is to say a function of x that we'll discuss later. A relation is a function if each x value has only one y value. An example, we have 1, 6, 2, 7, 3, 8 as ordered pairs. Let's do a mapping. 1, 2, and 3, that's the x. And let's do the y. The y is 6, 7, and 8. And the 1 goes with the 6. The 2 is mapped to the 7. 3 is mapped to the 8. So, note this relation. The relation is a function. And by definition, that means that each x value has only one y value. So we have a function. This relation represents a function. B, we have the ordered pair. Let's do the mapping with an x mapped onto the y and see what we have. X is 0, 2, 2. So we got a 0 and a 2. We don't repeat the 2. And we got a 3, 1, negative 2. 3, 1, negative 2. So 0 is mapped to 3. 2 is mapped to 1. And 2 is also mapped to negative 2. So notice that the 2 is mapped to 2 y values. So that means that the relation is not a function. This relation doesn't represent a function because if x is equal to 2, then y is equal to 1 or negative 2. So that's 2 y values, which you can't have. Let's continue. So just remember, in a function, for each x, you have exactly only one y. Which relation is a function? Explain. So this is practice. So you see if you could say it's a function or not. Is it a function? Well, let's see. Negative 1, 0, 2 are the x's. 2, 3, 1. So negative 1 is going to the 2 mapped. 0 is mapped to the 3. And 2 is mapped to the 1. So yes, the relation is a function. Reason, each x, each value of x has only one value of y. Yes is the answer. The relation is a function. And let's look at the next one. We had an x mapping to a y. So we got a negative 3, negative 3, negative 3. Oh, negative 3 is once. We got a 0, 1, and a 2. 0, 1, and a 2. So negative 3 is mapped to 0. Negative 3 is mapped to 1. And negative 3 is mapped to 2. So is the relation a function? No. Why? Because when x is negative 3, y is equal to a 0 or a 1 or a 2. So that's the negative 3 can only be matched to one y value, but here is mapped to the 3. So the relation is not a function. Number 3, let's see, we have an x and we have a y again. So x is negative 2, 0, 1, negative 2, 0, 1. And the y value is negative 1, negative 1, and 3. So one of the negative 1s will do it, and a 3. So negative 2 is mapped to negative 1. 0 is mapped to negative 1. And 1 is mapped to 3. So each x, when x is negative 2, y is negative 1. When x is 0, y is negative 1. So yes, y, each value of x is mapped to one value of y. Even though there's only one y, but each x has only one y. So each value of x has only one value of y. And number 4, we have, let's see, x and y mapping notation. We got a 1, 8, and 8. A 1, and we got 2 8s, and for the x, we'll only write down one of them. We got a 2, negative 2, 1. 2, negative 2, 1. 1 goes to 2. 8 goes to negative 2. 8 goes to 1. So each value of x is mapped to only one value of y. So this is not a function. No. Why? Because when x is equal to 8, y is negative 2 or 1. So each value of x can only be mapped to one y, but here it's 2 of them, so it's not a function. Also, what I want you to note that in number 2 above, number 2, the negative 3 is, notice in number 2, the negative 3 is repeated. And in number 4, the 8 is repeated. And notice these are not, the negative 3 is repeated, the 8 is they're not functions. So if the x coordinate, if the x coordinate is repeated, the relation is not a function. Just another way of saying it. So if x repeats, then you have 2 or more y's, then you do, it's not a function. Just another way of thinking. For each x, we have exactly one y. So if x repeats, that means we got more than one y, so it's not a function. Let's look at the graph of a relation. The graph here, we have this point, we have this point, and with this point. Is this relation a function? And the answer is no. Why? Because if you look at it, when x is 1, y is 1 and y is 3. So it's this relation that we have the dots for is not a function. Let's look at b. We have this one and this dot, and this dot. All these dots are here. We have all these points. And notice there's x is 1, x is 3, x is 2, x is 1, x is 0, x is negative 1, x is negative 2, x is negative 3. So notice two ways. The x is not repeated. Or for each x, you have exactly one y. So when x is 3, y is 3. When x is 2, y is 2. When x is 1, y is 1, so on. So this relation here represents a function. Why? Because each x value has only one y value. Or we could also say, if you want, x is not repeated, which means for each x there's exactly one y. Let's look at C. We have this point and this one, These, I'm shading them in. There they are, so we make sure that you can see them. Notice that right here, when x is 1, y is 4 or negative 3. When x is 0, y is 3 or negative 2. When x is negative 1, y is 2 or negative 1. So we have three examples here which they repeat. But when you're given the answer, you only need to state one of those pairs. You don't have to state all of them. So this is not a function because when x is equal to, let's say, 1, then y is equal to 4 or negative 3. One of them will do. You could use x is negative 1. You could use x is 0 and pick up these two. You could use x is negative 1 and pick up these two y values. So we only need one of them. We don't need the three of them. And again, x is repeated. So that's why. So when you look at a graph, you just got to look up and down the graph to see if there's two points that are the same with the same x. That means it's like on the same vertical line. Okay, let's continue. And a bit of practice. Practice means which relation is a function. Explain. Here we go. We look at, here's the points there. They're all dots. So we notice that the first point, right here, all these are on a vertical line. That means they all have the same x coordinate. So is this a function? No. Reason? Because when x is 3, then y is 0, 1, 2, or 3. Y is 0, or 1, or 2, or 3. So we got 4 ordered pairs which have the same x. So notice x is 3, and I'll just do this. So we got x is 3 4 times, but the y is a 0, y is 1, y is 2, y is 3. So we have, for each x there should be only one y value, but this time we got 4 of them. So it's not this relation is not a function. Number 2, we have this ordered pair, this one, this one, this one. We also have, this is why I'm enlarging them so you can see them. So there they are there. And is this a function? And the answer is yes. This relation is a function. Why? Because when x is 2, y is negative 2. When x is 1, y is negative 1. When x is 0, y is 0. When x is negative 1, y is 1. When x is negative 2, y is 0. When x is negative 3, y is negative 1. So we have x is not x is not repeated. So this is a function because each, spell it right, for each value of x, there is only one value of y. Or x, we could say x is not repeated. So if x is not repeated, then we have a function. The relation is the function. Number 3, we have a point right here, and a point there, and a point there, and a point there. So we go like this. When x is -2, y is 2. When x is 1, y is 3. Over here, when x is -2, y is -1, and y is 2. Oh, so this is not a function because -2 repeats. And what does that mean? That means when x is -2, y is -1 or 2. So it's not a function because for each x there are 2 y's, not exactly 1 y. So that's defining a relation as a function by definition. For each x there's exactly 1 y. That brings us to the end. If you like my video, click the like button. Click the subscribe button if you're not a subscriber. Click the notification bell. More videos are coming your way. And if you'd like to write a comment on my video, do so. And visit my math website, www.mathfullyexplained.com. 3 sections, me, my degrees and teaching experience. The video section talks about the strategies you're going to use to help you learn your math. The content section has the topics that I'm going to have on my YouTube channel, plus the number of videos. And the black font has the topics that are already online. And the red font is the topics that I'll be developing in the near future. Thank you very much for viewing my video. Bye-bye.